So, guys, check out figure 13.6, and because I couldn't find that picture, in online. That's why I say check out 13.6. You can see that that the top image has a narrow sector width, right? The top image has a narrow sector width, so it's going to be able to have higher frame rate. Okay? But you see, it's not changing the image at all, right? Nothing's changing about the image. It's just the time to create that image is being acquired a lot faster. That's the only difference. It's not changing the quality of that image per se when we're talking about narrowing the sector width. We're talking about adding focal zones. We're changing the quality of that image now.
So that means it has nothing to do with lateral resolution?
Nope. Only number of focal zone has to do with lateral resolution. This is not changing the image quality. You change the sector width.
We don't.
You're not changing the image quality. You're only changing the speed in which the image is being acquired.
But when we change the speed, that affect the resolution or
Okay, you change. I'm saying the quality of the image. You're just changing the time it takes to create that image. That's all you're changing when you're doing sector width or field of view.
Which view better image? The narrow sector or the wide sector?
Is the image going to be the same? Look at your image right here on the top right. That image is exactly the same. You're only changing the time it takes to create it. The narrow sector, I'm going to be able to create that image a lot faster than if I have the wide scan. It's not changing the quality.
What about the information? We use less information.
Yeah, you get less information, but that is only about the time. It's not the quality of the image is the same.
I mean, not about the temporal resolution, but when we use the wide sector, the quality of the picture will be less.
No.
Of the image?
No, the quality is going to be the same. The quality is going to be the same.
It was the difference.
It took longer to create that image. That's it. That's it. It just took longer to create that image.
And when we use the Doppler,
That's something else. Now you're making it even longer to create that image because you're adding an application on top of a 2D image.
Yeah.
Every time you add something, then you're going to decrease the temporal resolution. You're going to decrease the frame rate because now it's taking longer to create that image. So yeah, when I add pulse wave Doppler, when I add color Doppler, now it's taking 3 times as long to create one image.
so this is just for the time, but the quality of the picture the same?
The same. The same.
Oh.
Okay. So again, you see right here, quality is not being affected. Okay. But when we're talking about sector size, just sector size, the quality is not being affected. Okay. So with a narrow sector, we're going to have fewer pulses per frame. Remember, we had 16 versus 8 or something like that. Okay. We're going to have a shorter T frame, right? Higher frame rate and better temporal resolution when we're having a narrow sector. Yes, ma'am.
Does that mean like whenever you have the narrow sector and you freeze it, you go back, you have more?
Possibly. You may have if you freeze it in the same amount of time that you froze it the wide sector, definitely you're gonna be able to have more frames. Exactly, you're gonna have more frames because we acquire more images in a shorter amount of time. Absolutely.
Is that because with the color you don't take like that many images? Whenever I do the color and I go back, it's just like we're confused.
Right, because the color is slowing down the frame rate because now it has to send out scan lines for the 2D image and it has to send out scan lines for the Doppler image too. Because all Doppler is, you have your 2D image, then you have your color Doppler right on top of that image, then you have your pulse wave Doppler right on top of that image. They all working at the same time, so a scan line needs to be created for each application you add.
So the T frame is getting longer, so that's why you get less frame rate.
Absolutely. The T frame is increasing, the time it takes to create one image is increasing, so now frame rate is going to decrease because it's taking so much longer.
Can you talk about where it says, you got fewer pulse frames, per frame, which causes a shorter T frame. And by causing a shorter T frame, that means what again?
You're gonna by shortening when I have a narrow sector now, I have a narrow sector meaning that I'm no longer having a big image where I'm using 100 scan lines. Now I have an image where I'm only needing 50 scan lines. Okay? So now it's gonna take me less time to create one image because I'm using half the time. It's gonna take me exactly half the time to create one image now because I went from 100, to 50 scan lines now.
And my higher frame rate, what's going on with that?
So then I have higher frame rate because now I'm creating more images per second.
And they're giving my superb temporal.
Absolutely, absolutely. So if I'm able to create more images per second, I'm getting better temporal resolution because of that. Because of that. Again, guys, please know those relationships right there. That's really gonna help. That's like the summary of this chapter, honestly. That's the summary of this chapter, and just in the simplest terms. Okay. Our last one, guys, is line density. Line density is the spacing between the sound beats. Okay. This has to do with detail resolution. Okay. So the number of focal zone has to do with lateral resolution, right? If I increase the number of focal zone, I'm increasing my lateral resolution, but I'm decreasing my frame rates. Okay. But when I'm talking about sector width, it has nothing to do with image quality. I'm only increasing and decreasing temporal resolution. Okay? Now I'm talking about line density, meaning that this space right here, the distance from this space compared to the image from the distance to this space, now I'm changing the detail resolution because now I'm sending out more scan lines because now I want to cover more anatomy. That's going to make my image more accurate, right? My ultrasound machine don't have to make up that information. That's what the ultrasound machine really does. When it's missing information between each scan line, it has to kind of make up that information that's missing. Okay? But now when I have a much a heavier amount of scan lines, now I'm getting better image detail. Okay? But I'm also adding to the number of scan lines per image now, and I'm going to decrease my temporal resolution. Okay? So line density is also number of pulses inversely related to the frame rate. Okay? If I increase the number of scan lines on per image, line density is also a toggle switch on the IU-22. If you guys want to go after class, I can show you all three of these things. Probably not multifocus because I was looking for it. That's why I had that video for multifocus. But as far as like sector width and line density, I can show you the button where you can change your line density. Okay? So lines that are spaced far apart have low line density. This image right here has low line density. Okay? Our image has a low line density. Okay? It requires fewer pulses to create that image, and it's going to have a higher frame rate when we compare it to this image.
What's N?
Huh?
N.
N is that's referring to line density. That's referring to line density on this particular image right here.
So it's the distance between
Two
pulses?
pulses, exactly. It's the distance between those two pulses.